So welcome everyone to our USC GIS Day 2025, Integration and Use of AI in GIS Research and Practice. And we are so honored to have a fantastic panel of speakers with us. Today we have Greg Amon, Water GIS Manager, Los Angeles Department of Water and Power, Matt Bauer, senior full stack developer in the IT WILE department of Portland General Electric. He's also the founder of GeoForge, and he's doing a MS in systems engineering at Johns Hopkins. He's also an MS in GIST from 24 from our programs, and um, was in the U.S. Marine Corps 6 years. And we also have with us Justin Saris, Assistant Director of Information 2, Los Angeles Department of Water and Power. And lastly, we have Dr. Cece Wang, an Associate Professor teaching of Spatial Sciences with the Spatial Sciences Institute. So today we heard from a number of people, the kinds of work related to AI and geospatial technologies that they're interested in hearing about, especially students, and in particular the job market and what are the demands in the job market. So we have, for example, some prompts, some questions that we will have shared with the panel, and they have prepared to talk about these questions, some of these questions, what skills are most needed in the work domain with the advent of AI and all the emerging technologies. Currently, there are very big fears in the industry about different elements in the workforce being placed with AI. What skills can can the students in particular take on that can ensure that you find employment? Is AI now part of job application tests? In particular, thinking of our geospatial technologies coding tracks. How do you approach discussing AI in a job application when you're hiring people? And are there take-home tests or these tests that people have to do on premise when they come for an interview? So these kinds of questions, I think, are at the top of many of our students' uh, concerns, and at the same time, they're very, very excited about all the new possibilities that AI brings to the table in the job market as well. So I will stop sharing at this point and lead to our first speaker, which is Justin Harris. So please, Justin.
Sure. Thank you very much. Let me go ahead and share my screen. And I assume you can all see that?
Mm-hmm.
Okay, awesome. So first of all, thank you so much for having us here today. We're excited to share what we're doing here at LADWP around GeoAI, and particularly around what we're planning to do with digital twins. So I'm sure many of you know this, but some may not. LADWP is the largest municipal utility in the United States. And of course, we manage water and power. And what you may not know is we also have a significant telecom system that we manage across the city of Los Angeles. And of course, that spans, different geographical features, mountains, canyons, dense urban neighborhoods. And a lot of our infrastructure is decades old. And real-time events happen every day, from water main breaks to outages and wildfire risks. And because of all of this scale and pressure, we feel that GeoAI is going to become a huge part of how we work. It's going to help us find patterns that we can't see manually, predict failures, clean massive amounts of data, and help keep our digital twins accurate. Those digital twins are going to let us model how our systems behave, where risks are growing, and really enable us to respond faster and safer to all of those issues. We're going to walk through a few examples: wildfire and vegetation detection, water main break prediction, hydrant readiness, a little bit about our utility network migration, and how we're planning to use imagery to help us understand the condition of a lot of our assets, especially on the power side of the house. All these pieces really tie together to support public safety and reliability for the city of LA. And we hope that this will give you a good sense of how GeoAI is going to shape the future of utilities, and especially here at LADWP. So as I mentioned, LADWP is the largest municipal utility in the United States. We, of course, serve the entire city of Los Angeles from the mountains all the way to the coastline, and every type of environment in between. You know, we've got canyons, dense urban neighborhoods, hillside homes, industrial corridors, and we have a lot of remote transmission paths as well. And as I said, we manage water, power, and telecom infrastructure that in many cases, a lot of that infrastructure was built more than 100 years ago. And what kind of separates DWP from other utilities is that we handle two of the major utilities for the city, water and power. That's usually not the case in large urban areas. Because of that scale, complexity, as well as the expectations of our customers, we really feel that GeoAI and digital twins really aren't just nice to have anymore. They're becoming essential tools for our modern operations. So one of the biggest challenges that we face here at DWP is the sheer scale of our service territory. It's really simply too large for manual monitoring or traditional inspection cycles. Another challenge that we face is our aging infrastructure. We have valves, water mains, power poles, transformers that in many cases are decades old. And many of these assets are buried or installed in areas that are hard to access. We had, for example, a major outage in part of our northern service territory not too long ago in the Granada Hills area, where we had a valve that was installed, I think, in the 1950s or 60s that failed, you know, and it took a lot of effort to replace that. So that's an example of, you know, some of our aging infrastructure issues that we're dealing with. And those field teams that responded to that event respond to events every single day. Again, from water main breaks to power outages to hydrant issues, and of course, the ever-present increasing danger of wildfire risks. Unfortunately, these events don't just happen one at a time. They kind of come in groups, and they don't always happen in easy-to-reach places either. Public safety expectations are extremely high. Our hydrants have to work. Our water quality has to be protected. Our electrical circuits have to stay reliable, and we have to minimize the risk of wildfire ignition potential. So on top of all of this, our operational data is spread across many systems: water system, power system, telecom, our legacy GIS environment, and we have multiple databases that have been around for, in many cases, a number of years as well. And a lot of these systems were really never designed to work together. So that's an issue that we're having to tackle as well. And when we talk about building our digital twins, what we're talking about really are real-time models of how these systems function, our water network, power network, and telecom. And the accuracy and cleanliness of the underlying data that feeds those systems is really a top priority for us. So when we talk about digital twins, we're talking about dynamic models of our water and power systems that update as real-world conditions change. So a digital twin will let us see our system's current state, run predictive models, plan for emergencies, forecast failures, and even let us test future scenarios. You know, we're seeing increasing demand of electrical vehicles, which puts additional load on our system. So we'll be able to model those and see how our system responds. A digital twin, though, is really only as good as the data feeding it, right? So if your hydrant data has gaps, or if your water main has a wrong type of material assigned to it, or a power pole is leaning and nobody really knows about it, or if our conduits are misaligned, then the digital twin are going to reflect those errors. So GeoAI is going to help us keep those digital twins accurate. specifically, it's going to help us clean up our data, which we have massive amounts of. It's going to help us fill in some of that missing information, help us flag suspicious patterns in that data, and also help us process imagery so that the model stays aligned with our real world conditions. So GeoAI is going to give us the ability to find patterns across these massive data sets that no human could realistically analyze manually. It's also going to help us predict failures, as I had mentioned, water main breaks. We're also looking at using it to help us with vegetation risks and pole conditions before they can cause damage to the system or endanger the public. We're also looking at it to help us automate some of the slowest parts of the GIS data cleanup efforts that we're undertaking right now, which is really a huge benefit to us when we're preparing for our utility network migration. It also strengthens our digital twins by constantly feeding them cleaner and more complete data. We're also looking at it to help support better decisions and faster decisions for our staff in the field, especially during critical times such as outages, water main breaks, wildfire threats, or storm events. Those are, heat storms, or like the storms that we had over the past week. Those are always high periods of activity for LADWP, where our field crews really rely on GIS data. And GeoAI is also helping us to connect previously separate domains. Again, water, power, telecom, vegetation, data, imagery. That enables us to have a unified understanding of what's happening within our city and our service territory. So a couple of examples of GeoAI in action and how we see it benefiting, in practicality here at DWP. So as you know, wildfire risk is one of the biggest challenges that we're facing, and it continues to be an even bigger risk as we move forward with global warming and drought and everything else. So, and it's really impacting the high fire threat districts across LA. So we're going to be using LiDAR, high resolution imagery, and AI models to detect vegetation that's too close to our power lines. And the model will not only help us to identify current risks, but also spot areas that are trending towards dangerous clearance levels based on growth patterns of the specific species within a given area. So this is going to help our power system prioritize tree trimming work and reduce ignition risk. These results also will update our power system digital twin so that our planners and field crews will have real-time picture of vegetation conditions across the entire system. So we're also planning to use GeoAI to predict which water mains are most likely to fail. So the model is going to look at things such as pipe age, the material type, soil characteristics, corrosion risk, and historic break patterns. With thousands upon thousands of miles of pipes that are buried throughout the city, this kind of predictive capability will help our water distribution team focus on the areas where repairs and replacements will have the biggest impact to our system stability and reliability. And again, this not only prevents costly breaks, but also improves reliability for our customers, which is paramount to us here at LADWP. This information also will feed into our water digital twin so that, again, it can reflect the system's changing risk profile over time. What you may not know is that LADWP also supports the LA Fire Department with hydrant information, and GeoAI will help us detect unusual hydrant conditions. So as an example, we're looking to AI to help us spot locations where our flow readings or pressure patterns don't make sense, or where inspection activity looks to be inconsistent, as these are often early indicators of hydrant damage, sediment buildup, or access issues to that hydrant. And of course, for LAFD, that insight is critical. For our LADWP water folks, it helps improve their operational readiness. And of course, in the digital twin, it helps keep our hydrant conditions accurate so that emergency planners have the information that they need during the emergency response. Now, I mentioned it previously, but we're in the process of migrating to our to the utility network model, and it's probably the largest GIS transition in LADWP history. GeoAI is helping us to accelerate this process by detecting topological and connectivity issues, things like mismatched attributes, gaps in our network, overlaps, or features that really shouldn't be connected that don't make sense. Correcting these issues manually would take months or even years because of the volume of data that we're dealing with. So with GeoAI, we're able to detect these patterns and that repeat and fix them at scale. The utility network is going to become the base layer for both our water and power digital twins. So getting accurate data into that model is critical. The digital twins simply won't work if we don't have accurate data. So GeoAI is really critical in this respect. One of the other areas that we're really starting to focus on is the use of computer vision models to analyze imagery of assets such as power poles and our overhead lines. So GeoAI can help us detect leaning poles, missing hardware, damaged cross arms, sagging lines, poles that are rotten, which are unsafe to climb and prevent us from doing a lot of work. And these things oftentimes aren't noticed until an outage occurs. Even sometimes when we have visual inspections, we're unable to detect whether or not we have rot at the top of the pole. So using drones to fly above it and then analyzing that data will help us to get a better understanding of the condition of a lot of these assets in the field. And this is also especially valuable after storms or in remote areas where it's difficult for our crews to get to. And again, we plan to use these results to update our power system digital twin so that our planners and our engineers have better understanding of the condition of the assets across the system. So outages often follow patterns, of course, and certain equipment types, certain neighborhoods, they often occur during certain seasons and areas. And GeoAI can help us to identify those hotspots of outages. Of course, this helps us improve our reliability planning and helps our operations teams understand where these repeated issues are happening. Again, these patterns feed into our digital twin, so they reflect not just asset locations, but actual system behavior as they change in real time. So, as was mentioned, what are some of the skills for students? So for students who really want to work in GIS, GeoAI, or utility modernization, these are a few of the skills that really stand out to us here at DWP. So Python is huge. Even scripting will give you a big advantage. Understanding data modeling and how you work with complex systems like water and power are also fundamental. GIS fundamentals are also essential. Coordinating systems, topology, and network models. And communication skills really matter just as much as technical skill. You need to explain what your model is doing and why it matters. We often interact a lot with our business folks, so having those communication skills, in addition to the technical skills, are really important to us. And really, utilities are a great place to start your career because the problems are real, the data sets are huge, and the work really has a direct impact on people's lives. And I think that's why a lot of us started working here at LADWP. So in closing, I hope this gave you a kind of overview of how we're planning to use GeoAI and digital twins that are quickly becoming core tools here at DWP. I mean, GIS has been a core tool, but the GeoAI and the digital twins really are going to be foundational for us moving forward. They're going to help us a massive service area, modernize our 100-year-old systems, and improve safety and reliability for the citizens of Los Angeles. And we're really just getting this process started, and there's a lot more ahead of us. So thank you for your time.
Thank you so much. That was excellent.
Sure.
Next, we'd love to hear from Greg.
Yes. Good afternoon. Um, Justin's covered a lot of ground, and I absolutely second everything that he's said. So I guess the question I need to answer is why would you want to hear from two people at LADWP with the same awesome haircut? I assure you this is not the official department dress code. So my name is Greg Ammon. I manage the Water GIS group in the Water Engineering and Technical Services Division at LADWP. We exist to maintain the single authoritative GIS mapping and network topology record for the entire water distribution system, from where all of the sources of water enter the city, all the way down to the individual customer services connection. And to give you an idea of the scale, there's over 7,300 miles of pipe that run throughout the streets of Los Angeles, with over 200,000 valves used to operate that giant machine under us all the time. I started my career in mapping in this same group 32 years ago. I was creating and maintaining maps with pens, ink, and Mylar, and have actively participated on the journey as this craft has evolved from what it was to what is now a fully GIS discipline. My hope for contributing to this panel will be to offer perspective from the many hats that I've worn along the way, from cartographer, a GIS data designer and modeler, a GIS data creator, a GIS analyst, an application and software developer, a trainer of other GIS professionals, and as the manager of the group, I also represent an employer of those full range of positions from entry level all the way to mastery. As far as what we're looking forward to using AI, Justin has covered nearly all the ground there is there, so I'm not going to reiterate his list, but rather pause on one thread that popped up in nearly every single example, and that is using AI to improve the quality of our data. It's important to understand that we are the owner of an authoritative geospatial data set. Errors and omissions can have real impact on people's lives. And while we make no claims for perfection, we have an obligation to stand on a provenance of engineering design drawings, construction records, field observations, to put forth our best available truth of what our assets are out there in the field. And if any of you have ever seen that AI video of a particular celebrity eating spaghetti, the notion of creating GIS data with AI sounds kind of at odds with our calling for a geospatial data set. So I'll give two illustrations of where the AI helps. First, our data is a more than 140-year-old legacy of human record keeping. Our data is vast, and while we don't really have much trouble fixing errors, our big problem is knowing where to look. The differences between an AI data set, even though an AI data set may introduce its own errors, but the differences between that data set and our own are become beacons for areas that need research for correction. And second, just like with the engineering drawings, the construction drawings, and everything previously, our confidence in our data is based on how well it cooperates with the other records. An AI data set that agrees with what we have provides yet another level of corroboration and another level of confidence in that what we were saying exists at a particular location actually does exist. Kind of turning to the prompts, some of the fears I see in our area, and I think the fears we're feeling are not necessarily of a total wholesale replacement. Wherever you imagine yourself in the GIS employment ecosystem, whether you're authoring a beautiful award-winning map or coding a mission-critical GIS application, there is always a journey from entry level to mastery that we all hope to be gainfully employed along that journey. The fear is not that AI will get so good that there's no need for us to even entertain the idea of this career. I think the fear And as an employer, I think the fear is that AI will get just good enough, just mediocre enough at composing a quick map or generating the baseline code for an application, that the job opportunities between entry level and good enough will dry up, leaving us in a situation where, there's a clear opportunity for experts and masters, but almost no way to get there. As an employer, I want a crack team of GIS masters. And I also ask the question, where will they come from? Obviously, we have to develop them, but the future's a little uncertain. And finally, as far as the skills, over my career, I've seen many skill sets rise and peak and sunset, and the skills that fill the voids that those leave behind haven't always been obvious when you're looking forward. They become obvious when you get there, obviously. So I have very little to offer you in specific skills, other than maybe just a few guidelines. Data, the first is that the data answers the questions, not the tools. Becoming a subject matter expert in an area of data or an area that interests you may be more valuable than being the expert that knows about every single tool available. Being able to develop that intuition to know when something looks right or when it looks wrong and needs investigation. And last, that every map, whether it's printed or interactive, is above all a communication tool. And each map has a unique message and a story that is worthless if it cannot effectively convey that message to other humans. And other humans have emotions, they have good days, they have bad days. They have a context that only another human can understand and refine the product of AI to effectively communicate. And so maybe work on the skills of effective visual communication as a hedge against what other skills AI may make obsolete. That's it. Thank you very much.
Thank you so much. That was excellent. It's fascinating, like hearing the range of things that you've been involved in, and you've seen the whole evolution since the drafting board. There are a few of us around still that remember the drafting boards and and when CAD took over,
Oh,
even
yeah.
as far back as that. Yeah. So thank you. Um, so we'll go on to our next speaker, Matt Bauer.
I'll go ahead and share screen. Let me make sure I choose the right one. All right, there we go. So thanks for the introduction, Dr. Swift. I'm Matthew Bauer. I'm a senior full stack developer with Portland General Electric. I do a lot of things. I also have my own LLC, GeoForge, that I do a variety of side work through. And I started a second master's at Johns Hopkins doing systems engineering just to kind of round out my skill set. And frankly, I have more GI time left, so I kind of might as well. So today, I will say a lot of the stuff that we do with AI at Portland General Electric won't really be able to highlight. It's a private entity. I'm not here representing them, speaking on their behalf, all those kind of standard disclaimers. And then most of my side work clients also have to sign NDAs for them. So I thought maybe one of the most helpful things I could do for you all is just show the submission that I had for the Esri Innovation Program at USC during my time there, kind of walk through the web application I built, highlight some of the different ways that I used AI to assist with my thesis. And then there is one thing that I want to highlight at Portland General Electric, how we're kind of innovating using AI to assist with wildfire mitigation. Like Justin and Greg said, I mean, the challenges facing utilities right now are numerous. AI is an incredibly powerful tool to deal with those things. I think the future is a little uncertain for everybody, but right now, at least, AI is a powerful tool that we all have to learn how to use. So for my thesis, I developed a web application and an overall software system, ETL pipeline, whatnot, for a community wildfire protection plan repository. This was building off of research that I did for Portland State University, which when I show you the website, you'll see that they are shown on there, their logo for that reason. I used AI to really work on all aspects of this. At this point, I will say it was mostly generative AI for this work. While I was working on this, I was also working for Three Gimbals, a small defense intelligence firm, doing a lot more dynamic AI work, working on retrieval augmented generation pipelines for Neo4j graph databases, for Postgres relational databases, lots of different stuff. But for this, it was really generative. So I was using ChatGPT for assisting in the creative side of it and just ideas and whatnot. I'm a programmer. I'm like inherently not a creative person. I just like solving problems. So in that aspect, I really leaned on ChatGPT, like, hey, here's the problem, here's what I've done. Kind of what would your approach be here? I will say with generative AI in particular, a lot of the time the first results you'll get back are not that great. You have to really work through it. It's a lot like coding. It's iterative development. It's starting small and scaling and building something bigger. So with AI, I would say, you always have to be ready to push back, to point out mistakes it makes, because it does still make them. We're not at super intelligence yet by any means. For this kind of shows the system that I built out. So the front end was just vanilla JavaScript, HTML, and CSS, using Leaflet for the mapping, the styling, lots of interactive functionality. And then, like I said, the Esri Innovation program, you have to use Esri something. So I'll be honest, kind of to meet that requirement, I threw in some hosted feature layers from ArcGIS Online, use the ArcGIS SDK for JavaScript, back then called the API. And then I also coded my web server in JavaScript, set up the file system, just basically all the static files in the repository. And then for the database, I used Postgres and PostGIS for all that data. And I stored that in the AWS relational database system. I will say, going back to the time that I did this, I probably wouldn't go with AWS. I mean, to be fair, it's been useful. I use AWS all the time. That's what we use for everything in PG, basically. And it's large and it's complex, and it's a tool that you should all learn. But for a smaller project, I think a lot of the time, something like DigitalOcean is lower cost, it's more lightweight. You actually are doing a lot of it just in that raw Linux server instead of using the graphical user interface or some type of CI/CD pipeline. So this was the story map for my Esri Innovation Program submission. I did win that award for USC, so I think it was successful. But I had a lot of fun going through that program, and I would highly recommend that you all, at least those of you that are, in kind of the programming realm or really anything else relevant, pursue that as well. So for this was the application that I made. We've got a little ribbon out of the way. Pretty standard web mapping interface. I'll be honest, halfway through my thesis, I had like a huge family medical health emergency happen, so I lost about a third of my time. That's why the styling is like all pretty plain and not great. But I developed like the pop-ups. These are all community wildfire protection plan areas. I gathered these doing research for Portland State University, got their permission to use it for this work. That work is still happening, and actually this might be starting to get used here pretty soon. So for all these boundary areas, you can click through them, see everything that exists where you click that intersects with it. And then all these PDFs for these plans are in Google Drive. They're all open source, all public information. And this is really a tool for wildfire managers, for people that deal with, preventing risk and disasters, to use to go back, see who did what, where I am previously, how they implement those things. I know at a lot of these organizations, it's not always like a clear documentation trail. I mean, at PG, it's a big company, and sometimes something is done by somebody in the past, and you have to kind of cobble together the steps to get there. So this is basically providing that history for them. That's kind of the simple aspect of it. You have all your basics. You have some filters to go to individual states. I used generative AI to help code these things. Really, I mean, the important thing to remember is you still need to learn like JavaScript, Python. You have to understand these coding languages because they will make mistakes. Like, let's say after graduation, you end up working for a utility company. I'm sure Justin and Greg are in a similar situation in LA where cyber threats are very, very, very real to our electrical grid. I mean, it is really something you have to be incredibly careful about. So you can't really just take AI, generate code. For us, it's good. You have to actually understand that code and make sure that you're following best practices, that you're creating an efficient, secure, useful website that's not going to be breached by adversaries. So some of our other standard things, a legend, Hosted feature layers. This was the part that I put in to kind of get into this program. Like I said, ran short on time, so don't have pop-ups, a lot of the standard things. But these are live data from ArcGIS Online, I believe, from the Forest Service. So you can kind of view those things, but the real meat and potatoes of this was the ability to add new community wildfire protection plans. So when I was working for Portland State as a researcher, we basically had to reach out to like all of these different bodies across these, I want to say 11 Western states. We really wanted to have a way for people to be able to submit their own plans to a master repository. Since I did this thesis, Esri has been working on like a community wildfire protection plan template, and basically becoming a place where people can put their plans. At the time that I made this, that didn't exist much yet, so I was trying to come up with a solution for it. I will say it does look like this actually might be used by Ohio State, Portland State soon, so I'm not going to actually submit plans to a database. But let's say we go in, and let's say we have a community that we want to put in a wildfire protection plan for. Here, let's go to my hometown. So we could go to that county. It's populating all these options using hosted feature layers, ArcGIS Online, go all the way down to Scotts Mills. And there's where I live. It's a tiny, tiny town. So let's say maybe somebody in Marion County is working on the Scotts Mills plan for whatever reason. They want to submit this in here. They can put in their email, all these things. There's field validation on everything, so they do have to fill it out, put in their PDF. And then maybe this doesn't cover everything. Like right now, this is actually the urban area, but maybe they want to cover my house. So they can edit that plan. They can go in, stretch the boundaries right there. And there we go. Now I'm covered. So this is really just a way that you can submit these plans. It goes through a data pipeline that I developed. So basically, if you click submit, it would push this geospatial into basically a temporary table in Postgres, PostGIS, and then I receive an email. It has two hyperlinks, accept and deny. I can also reach out to the person that submitted this for any clarification. If I hit accept, it pushes into the authoritative database. You could refresh the website and that plan would be in there, or I could click deny and I would have to provide justification to the end user. So like I said, I realize this isn't like completely GeoAI, but I used AI for all aspects of this. If I was doing it now, I would definitely do it differently. Like back then, I would use ChatGPT to assist with coding. Now I use Claude Code for basically everything. Claude Code is awesome. You can use it at the CLI level. You can have it make API calls. You can have it do a lot. You do have to be very careful, I will say, like particularly if you work for a defense company, a utility company, something where there's a lot of IP and there's a lot of sensitive data, and you have to be really careful not to share that with AI where it could get into training data. For that, I do have some tools. I like LM Studio. It's open source. It's a really good way to just download some smaller models that you can run on your own hardware to do things like entity extraction, natural language processing, any of that kind of more simple stuff where you don't need like a massive number of tokens to handle it. Yeah, I really enjoy using AI for this, and I use it all the time for my work. So kind of to highlight one thing that PGE does that we've made public, although I will say Justin and Greg like hit on so many things that we're doing at PGE too. I'm sure across the industry it's happening. But we have a partnership with Pano AI for these AI embedded cameras that basically have a 360-degree view of places like this, where it's dense vegetation. So if we go in here, which is a public application where you can view all these cameras, let's say we can actually see one that had, no. Sorry, that is my 1-year-old son knocking on my door with a toy. So if we go in here, you can view that panorama and you can actually see, well, of course, it got cloudy since I reviewed this. You could have seen before it was cloudy, all the burnt trees and everything. But the real value of these cameras is they're embedded with AI models that use computer vision to basically identify ignitions. So let's say a fire pops up over here, well, that'll trigger cascading effects through automations that are going to alert all the necessary parties, mobilize crews, do whatever we need to address that. Yeah, it's one of our main systems. Like I said, unfortunately, I can't get into all the systems we're using. I will say digital twins are a huge thing. Like Justin and Greg pointed out, that is definitely something that PG is pursuing. and I would expect will be happening sooner rather than later. But there's a lot of uses for AI for companies that are utility companies for a whole variety. When I was at Three Gimbals, we were doing all types of cool stuff with them. I think Geesley Paulson was on this panel last year. He was my old boss at Three Gimbals. And we were setting up retrieval augmented generation pipelines to pull in information from graph databases for stuff like giving Ukrainians tools to track Russian groups that were moving through eastern Ukraine, to track resistance groups of their own, their recent actions, to consolidate large scale, like big data internationally of different events that are happening. And that's really been one of my favorite things with AI is building out like retrieval augmented generation systems with maybe functions that enable AI to basically write SQL, write Cypher, if it's graph databases, Neo4j in particular. But with things like that, like let's say you're using Postgres and PostGIS, you can have it write SQL, you can show the results of that on a map, you can have that AI really be like a consolidated database that users can talk to learn about all that data that your company has assembled. I think it's a super powerful tool. I'm sorry if this is a little brief. I wish I could talk about more of it. But yeah, I'm looking forward to the panel discussion.
Thank you so much, Matt. That was excellent. And now we'll move right to Dr. Wang.
Jennifer, for
Yes.
coordinating, and as well as thank you all the fascinating talks delivered by our industry guys. That's more from a industry perspective. So I gonna talk about the GeoAI more from academic and then a human-centered perspective. So let me just give me a second and share screen. Okay. All right. So yeah, so that comes to the topic of my presentation, human-centered GeoAI. All right. So let me switch. Okay, is that fully presented? The layout. Okay. All right. Yeah. So that's my topic, human-centered GeoAI. So starting from my research interest. Oh, by the way, I'm CC. I'm a faculty member here at SSI with research interest, particularly focused on the human and environment interaction. So as these two bubbles that you can see in the screen. On the human side, I usually utilize social sensing techniques such as natural language processing, human perception measure to quantify human behavior. And on the other side of the environment, I predominantly utilize remote sensing data and technology to quantify environment in terms of urban built environment and natural environment. And what is sitting in the middle of these two bubbles, that is a GeoAI. So the reason for that, given the relationship in between human and environment is usually very complicated and less likely to be a linear pattern. So that means it's less likely to be quantified by using any of like a simple linear algorithm, right? So that's where we have to heavily relying on GeoAI to tackle those complicated problems and the relationship. So because of that, that comes to two pieces of work, a review work that we have done dating back to the year of 2023. It's kind of a little bit background here. The geography had two branches, right? Human geography and the physical geography. And then for the physical geography, the people looking at the physical phenomena and then such as remote sensing. Those are the disciplines the GeoAI has been utilizing for like long term and very, very heavily. But on the other side, the human geography, that is where the traditional methods lies on, and then most of them relying on quantitative studies, from the social science perspective. Relatively less GeoAI utilized over there. So our interest is like, hey, let's see what's going on, from the human perspective, how we apply GeoAI in human geography. So that comes to the first review work that we have done in the first half of the 2023. followed by the release of the first version of ChatGPT in the end of 2022. So that's kind of a milestone that we are entering the era of AI, right? So so that's the first piece of the work. And then in the second half of 2023, we think that would be interesting to look at what is the generative AI. So in terms of large language model, foundation model, ChatGPT utilized especially in the geospatial studies and the education. That's kind of the motivation. So we have two figures here. The first, the left-hand side figure is actually presented in Justin's talk previously. So that's kind of crossover three bubbles. The GeoAI is positioned right in the middle. But don't forget, in terms of the AI family, we have different levels of complexity, right? So the AI include machine learning, further including neural networks, further include deep learning, further include generative AI. And then the very inner circle is LLM, so large language model or foundation model. That's where we can find the ChatGPT, DeepSeek, Google Gemini, all the fancy models lies in, right? So with that one, with that understanding, we can further narrow down the GeoAI to be GeoGAI. So that's kind of the AI circle outside and then narrow into the very inner circle. So that's a geo-generative AI. So that's how we frame these two pieces of work. The first piece of work is done by a multinational collaboration, 31 different co-authors coming from 5 countries and the regions. That's the way we kind of narrow down to scoping the review work by looking at the intersection of the human geography, which is again, is a big domain, but we break down into 14 different subdomains. Those are all from the human perspective, such as we have the historical geography, human economy geography, political geography, culture geography. Those are all looking at the human and the neighborhood and the community-based problems. And for the AI, we look at computer vision, deep learning, machine learning, and the natural language processing. So we collect all the keywords and then putting into the data sets. So finally, we retrieve 1,516 papers. That is where we collect all the data and then to kind of form the landscape that comes to this key Sankey diagram. So the reading of the diagram is the first column showing the application of the GeoAI across the 14 different subdomains of human geography. So the big proportion goes to, say, urban geography. That's where the pink string coming from. So that's indication, the urban geography is probably the most predominant subdomain of human geography utilizing GeoAI, which was followed by, say, the second one will be transportation geography. That's the blue string coming from. And then to the second column, study region, we will see China is contributing kind of the largest proportion of the empirical studies, which was followed by the US and multiple others. So that means multiple empirical studies, the multiple study regions involved into one piece of research work. And several other ones. So totally there are, I think, more than 100 countries involved here. And then the data type, which is also very interesting to see, remote sensing imageries, which is a big proportion in the landscape, which was followed by the transportation network and the government authority survey-based data sets, such as census data or community survey data. And the last one is modeling task. We will also see the big proportion goes to the nonlinear regression. So that is kind of a big modeling task that GeoAI can achieve, trying to find out those nonlinear complex relationship in between human and the environment. And it was followed by the image-based classification. So that's dealing with most likely to be the remote sensing imagery and as well as linear regression. That's again, find out the relationship. So that's kind of the overarching holistic picture of what's going on here in terms of the GeoAI application in the human-centered study. Yeah, so those are little figures break down into each, the distribution of the popularity of the studies in each of the domain. That is a country, and then that is a modeling task. But I'm gonna skip all the figures given our paper is basically it's open access. That's free download by everyone. And the reason I mentioned about this piece of work, given I think it can be a good starting point for many of our students as a newbie in this field. I usually receive the questions from the students asking to, hey, we want to learn GeoAI, but there are like millions of available algorithms in the literature where we should start. Yeah, so that's I think that piece of work serving as a starting point. You can download and have a read. And the most important thing, we provide a long list. It's a long table in the piece of work, summarize all the existing relevant algorithm has been utilized in the literature and further categorized into kind of different levels, say like a serving classification purpose, and then break down to see if that's an image-based classification or vector-based classification, and et cetera, et cetera. And then break down into each of the algorithms that we summarized in that table that you can easily catch up to say in any of your future work or even our industry partners, if you want to achieve a particular modeling task, what types of algorithm that you can utilize. So that can be a kind of a good reference and kind of handbook that you can check out, right? So that's kind of the whole picture here. Yeah. And then since the release of this review work in the end of 2023, we receive a lot of positive feedback from the local community, especially the students and scholars working in the GeoAI domain. So continuously, we developed this review work as a book entitled as GeoAI and Human Geography, which was quite recently released to the market. It was co-edited by Professor Xiao Huang from Emory University and Professor John Wilson as the founding director of our SSI, and as well as Professor Peter Kedron from UC Santa Barbara and myself. So it's there, and then welcome have a check of the website link that I posted here, and as well as there is a QR code that you can scan. Yeah, so that's welcome. The price like 159, but our paper is free, so you are always welcome to download and have a read of the paper. Yeah, and then for the second piece of the work, it's further narrowed down to look at the GeoGAI. So that's a geospatial generative AI, which is a very cutting domain in terms of the usage of LLM, ChatGPT, and the foundation model. So yeah, we collected all the keywords and then put it into the academic database. And finally, we retrieve around 30 different papers. At that stage, don't remember that's it's just 6 months after the release of the first version of ChatGPT. We have seen there are almost 300 something papers released to the in the literature, and then we finally narrow down to just look at 30 of them. But since there has been 2 to 3 years passed over, I think right now the amount of the work existing in the literature has been, I think, booming up. It's probably many times more than that time. So as a quick summary of the reviewer results, we can see the application of the GeoGAI more predominantly utilized in the domain of cartography, which is understandable, helping with generate imageries and then generate maps, which was followed by the geotechnical engineering. So that is a geo prompting, setting up the prompt to generate meaningful results. And then in terms of the data usage in the GeoGAI, generative AI, text is the predominant data input, which is also understandable given we are using LLM, right? Most of the input will be text-based content. And it was followed by RAST data. So that's such as the imagery, remote sensing imagery, or any of the normal photos, the pixel-based photos we put in over there. So that's as a reflection, GeoGAI predominantly utilized to dealing with photos and images. One of the most important summary of this piece of work will be we highlight the 4 roles the GeoGAI is playing at the current stage. In terms of serving as a purifier, so that is purify the data to kind of post-processing the data, and then serving as a converter, so that's a convert the data, generate a different format of the data as the outcome, and the third role is a generator, so that's a generate new data. And the last one, which is quite exciting, serving as a reasoner. So that's a GeoGAI can right now much facilitate the causal inference. So helping us to make a decision, find out the reasoning, and then justification in order to make a better decision. So that's the 4 roles the GeoGAI are playing right now. So yeah, so that's a summary of the work, and then I'm hoping that's kind of providing a little bit prompts. Then the students that you can ask questions, and then we can have more interactions. So right now I'm staying in my office. It's basically easy for me to manipulate the presentation slides, and then later on I'm going to jump to the conference room, which is just on the other side of my office. All right, I will see you guys over there.
Okay, so we have heard the wonderful 4 panelists talking to us about their field and their job and how they use AI in the GIS profession. I'm gonna open up for people online and over here in the conference room to see if there are any question to any of the specific or just the general questions are okay. Yeah, go ahead, Matthew.
Yeah, I had a question for Greg. So you were talking about AI and how we can use GeoAI to sort of check our work and look at where the human and the AI matches up and use that sort of corroboration. But my question is, given that AI can be known to have confirmation biases and it's trained on a certain data set, and that's obviously a human data set. How do we account for those sort of confirmation biases, either in like training the model or in our interpretation of the results in sort of reactive sense? Like how do we deal with those potentials?
Well, in our instance, whether it's biased or not, we're looking for kind of the canary in a coal mine of where we need to look for errors in our own data. If the data set is completely off, it'll become apparent right away when we start researching, areas where we find. We're not saying that because we disagree with the AI data that the AI is necessarily correct, just that these areas need further research. And, a human is going to have to go in and perform that. And, we have correcting information we have processes and programs for how to research and validate what is actually correct, short of digging it up, but.
Okay.
Any of the panelists would like to chime in for that question?
It just also, I want to say that here at LADWP, one of our, we have a number of AI or pillars for responsible AI implementation. And one of those is maintaining a human in the loop paradigm. So regardless of any output that we receive from an AI model, it always has to be validated by a human. So that's one of the other areas how we're guarding against, the fear of AI replacing humans here at LADWP. That will never be the case here. We see it as a tool for augmenting and allowing our human capital to focus on more creative endeavors and focus on, more human-centric related initiatives and AI helping us to help us automate some of the more mundane tasks. But regardless, the human in the loop paradigm is central to AI implementation and adoption here at LADWP.
Thank you so much. We're going to move to Stephen first, and then we'll have a question from one online. Okay, Stephen.
Yes, no, my question's also kind of geared to Greg and Justin specifically, but we had a wonderful presentation a couple weeks ago from Esri here at SSI, looking at the capability sets with augmented reality, XR in that direction. And my question's just wondering, is DWP using or piloting or planning anything using the adoption of those technologies, such as augmented service line overlays, or are they already implemented? I'm just kind of curious as to what your thoughts are both on that and what you've seen in the pipeline.
They're not today, to my knowledge. I don't, Greg may have more information, but we're not using any augmented reality solutions today, but they are being discussed. They're primarily, not specifically the Esri technologies per se, but other technologies that will allow, for example, our crews to perform simulated work in high voltage environments and use AR to perform those and train more in a safer environment than actually doing them in a live station. So there are a number of use cases for augmented reality here at LADWP. Some were explored some time ago when the technology was nascent, and I think there's opportunity now to revisit some of those. So they are certainly areas that we are exploring.
Yeah, and
awesome. Thank you.
Second,
sorry,
we've back in the day, as Justin said, we've purchased the HoloLens. We've explored all of the possibilities. Built a few VR models for training as well as product delivery and user review and things like that, but nothing has hit that magic button where it was go full bore on it yet.
No, awesome. And I know that's still something coming down the pipeline, but it seemed like you guys were, at least when the presentation, using it to identify problems, find those patterns, and it's moving pretty quickly. So I appreciate the responses. It's awesome to hear that. And I also didn't realize the depth of what you guys are managing there at DWP with both power and water being over across the country here. So very cool. Thank you.
Sure.
And Juan Cortez has a question online in the chat. I'm just going to read out loud here. I think the question is also for Justin and Greg for the experience implementing GeoAI at the LADWP. What have been the biggest challenges in moving a traditional utility from paper-based system to like the modern GIS digital twins? Because I think he has some experience in summer with Altadena water company over there where all the service records are still on paper, right? So I think it's very obvious, but I think how do we also, from your experience, how do we motivate agencies to begin transition? Like what is your experience?
So I've been at DWP for 25 years now, and I think Greg can second this. I think one of the biggest challenges that we face in implementing new technologies is, changing the mentality of, but we've always done it this way. That's kind of what we see all the time is like, why do we really need to modernize these processes? We've always done it this way and it works, it's always worked. So changing that mentality is kind of one of the biggest barriers that I've seen. Another big issue that I've seen when, moving towards more digital processes is not taking the time to actually embrace business process reengineering and automating antiquated processes. And what we end up with is something that's just moving a paper-based process to being a digital process. And we haven't really gained any efficiencies in the process. So I think that's probably one of the biggest issues that we've seen. Another area that we find that I think is kind of unique to DWP is that being a public entity, we are heavily unionized. So a lot of these, transitioning to these newer methods of doing work can sometimes threaten job classifications that have historically performed that work. And, we usually adapt to those by changing the roles of those folks and working with our union partners to kind of transition folks into new ways of doing work. But those are kind of some of the areas that I see, when moving from a paper-based system to a GI to digital, technologies. Another area, I think Greg can probably touch on this more than I can, is, we have so many maps that have been around for years. So digitizing all of that old data is a very laborious task. And I know that some on the power side of the house, they're still heavily reliant on some of these paper maps just because the volume of them and getting that data into the systems has been problematic.
Thanks so much. Matthew, do you have anything to add? I imagine that you also experienced some of these similar like experience.
Yeah, absolutely. So the thing that stood out to me the most, so at the Forest Service, I was a geospatial systems engineer, I think it was. Before I was a software engineer for PG, I was an analyst in the vegetation management department. A large part of my job there was moving like paper processes to digital. So moving from like paper maps to using Survey 123 and field maps for data collection and all that stuff. And it is really challenging to get like a large group of non-technical employees to embrace digital processes. Like for us, at any given time, we have like 500 tree trimming contractors out in the field, cutting trees, getting them away from lines, doing all that stuff. And to train all of them to use those tools, I mean, the amount of questions I would get just about like, why isn't this button working, are immense. And on top of that, there's a lot of non-English speakers that are doing that type of work. And so you have to basically translate everything. So you need not just like to build the system, and you can't really use the AI to translate everything. I tried, and they were all like, this is like not normal Spanish. Like this is like way formal. This is weird. And so I had to find Spanish speakers I'd worked with and be like, hey, can you please translate this for me? I can't translate it. ChatGPT is doing it like it's academia, and these guys are not into it. And so just the training the staff alone, that's like the biggest concern for me when I move to digital systems. It's a large process, and it's so important. Like if that user interface and user experience isn't intuitive and simple, like people are just not going to adopt it. They're going to go out, do everything on paper, come back to the office, try to jam everything in. It'll be a mess. So like you have to spend so much time making sure that it's easy for them to use, for them to actually be willing to adopt it in the first place.
Thank you.
Mhm.
We have one question from online from Stephanie Kim. I think this is for all the panelists. Is there a standardized ethical practice guidelines for AI in spatial sciences and geo AI? Do those guidelines change as AI evolve in its role in the research and the practical use? If not, how do you navigate? So I'll start with maybe asking this to Dr. Wang about how do you handle what do you think about the ethical perspective?
Yeah, sure. I would say most of the standard that we are having right now in terms of like data privacy and data management, we still stick to the kind of the traditional standard that we have been utilized in the past decades, which does not really impact too much by AI. But a very special thing in the era of the AI will be the AI generated data, right? So AI like right now serving as an instrument to generate a lot of data. So we need to be very cautious about the content generated by AI, not over trust on any of the content, right? And as well as how we share those AI generated content. Even though right now we are like writing papers submitted to the journals, we need to indicate, is there any of the content is generative AI generated? We need to kind of put in a disclaimer over there. So those kind of the newly added principles to the industry and as well as academia. So that's something we need to kind of update it and all the way stick to the cutting edge of the domain. Yes, that's a little bit 2 cents from my side.
Any of Justin, is there anything you think on the practical side that the use of AI that you guys think of a guideline for the ethical perspective?
So, again, we take a human-centric approach to AI implementation. We also are aware, I think it was mentioned previously, around the biases that can be inherent in some of the AI models. So we're cognizant of those. We have internal policies that state that when our employees use AI, they have to provide a disclaimer that AI was used to generate their responses. when we look at the potential for using AI on the operational technology side of the house, we never want AI to be able to make decisions on its own. With the rise of agentic AI, that becomes more and more possible. So we need to safeguard against those. And yeah, I think our policies will have to evolve over time as AI itself evolves over time. When ChatGPT was released initially and it was the hot topic, we were quick to develop an acceptable use policy for AI. We wanted to ensure that our employees weren't putting sensitive intellectual property into those models that could be exposed, unintentionally. As those technologies have evolved and we've started adopting tools like Microsoft Copilot that has security and guardrails built into it, those policies evolve. So yes, as we start to adopt these technologies and the technologies evolve, our policies will also have to evolve. But being aware of the limitations of AI is critical, and understanding and guarding against model drift and things like that are things that we need to take into consideration as we start to adopt this technology. We're still very early on, to be perfectly honest with you, here at DWP. We're very risk averse here because we deal with such a critical service to the citizens of Los Angeles. So we can't make brash decisions on technology adoption. So we tend to move rather slowly.
I really think I think Justin's been very humble. I feel like you guys have been moving quite a lot just based on your discussion about digital twin and then the Geo AI in action. So I think that's great to see so many changes in DWP. Is there anyone in here has questions in the conference room?
I have a question.
Yeah, go ahead.
Greg, you said that the data answers the questions, not the tools, know about the content, and this is for all of the panelists. Are there any areas of expertise or content or specific data that you're working with that you need, people that they understand those particular areas?
Mm-hmm. Well, let me give you an example of data that we work with the most are pipeline data. At first glance, it looks like a very homogeneous set of information. We've got the pipes, we've got the alignments, the geospatial data, the materials, everything about it. What you don't see, and what only comes from the experience of knowing where it came from and the provenance of it, is that the data of very old pipes, so back from about the 1920s to about 1950s, the city of Los Angeles grew very rapidly by annexing other cities and in turn annexing other water systems. And that the records that we have for those pipes, even though they look identical to all of the other records of pipe, they are potentially much older than because we have the record of when we annexed it. We don't necessarily have the record of when it was installed. And the time taken, the research, seeing those spikes of, in 1923, there's no way we could have installed 3 million feet of pipe. It's just not possible, but there it is. That those things can create anomalies in, way further down the line, especially if it goes through AI and you'd be scratching your head and wondering where the error came from. Knowing that specific information about the data, about the provenance of it, about where it, its history, that's what really helps answer the question and being able to address. I hope that answered your question.
Yes, yeah, that's great.
Thank you. We got a question to Matt. You mentioned the value of understanding fundamental scripting in Python and Cloud. Given the type of data you work with most often, are there other tools or language or software platform that have significantly improved the efficiency or support your workflow? I think this is a very, very solid question that our students are interested to know.
Yeah, absolutely. So the tools I use for the most part, I use Gyro for project management. I use Claude Code for code development. I use ChatGPT for general questions, for creative stuff, whatever it may be. I use Jenkins for CI/CD. I use AWS for cloud computing. I use DigitalOcean for cloud computing. VS Code for an IDE. Those are kind of the main tools that I use. Python, of course, like Justin and Greg, I think mentioned earlier, like probably the most universal important language to learn. Like Python is just in everything. I'm not saying that like C# and C++ and Java and JavaScript and all these different things don't still have their place. But Python is huge because you can use Python for backend web development. You can use it for data science, all that type of stuff. JavaScript, TypeScript, also super important. Frameworks, React is huge. I love React. React is awesome. So yeah, I would definitely focus on kind of looking into all those different technologies. Claude Code in particular, like I only really started using it because I had an interview with another company that does like, I don't know, it's a startup, the Flashpoint original developer started it. And one of my previous coworkers worked there and they were using LangChain for agentic AI and then they were using Claude Code. And so I started digging into that and there are like so many different things you can do with it, like creating agents, going back and resuming your old conversations, like really fine tuning it to do what you want, setting up settings files. So like maybe you have an env file and you have like really sensitive passwords and stuff in there, making sure it's not going to access that because like Justin and Greg mentioned, like companies are very concerned about like proprietary information and data getting into training data sets. So using all those tools has been super helpful and yeah, I love all of them pretty much. Except AWS. I kind of hate AWS, but it's best.
Anything that Greg, Justin, or Cece you want to cover in this perspective as well?
I think Matt covered a lot of the tools that we use too. I think the only difference really is like we're starting to pilot GitHub Copilot for some of our, our programmers are starting to look at that to help with code generation. We also are a GitHub enterprise shop, so we use GitHub Actions for our CI/CD. But a lot of the tools, like as I had mentioned previously, Python, JavaScript, we still have a lot of developers that write in C++. So I think, and it's kind of interesting here. We're still largely on-premise, so we really haven't embraced a lot of the cloud computing. Again, we're very slow to evolve. We are starting to delve into that area, but we still have quite a substantial on-premise compute environment today. So, we run our own enterprise Kubernetes on-prem and that sort of stuff. So cloud computing is coming, but still largely on-prem here.
I don't have particular comments here, given I always think academic most likely to be behind the industry. Yeah, it's a joke, but it's actually a reality. Yeah, so I mean, like always, we can always keep ourselves, keep self motivation, and then try our best to stick to the cutting edge of the domain. Like even as faculty members, we educate ourselves to to learn all the versions of LLM and. Or even quite recently, I registered like a Google AI education accelerating program. So that's available, providing no cost free resources. So those kind of software and platforms and resources are always available. So we can just keep educating ourselves and keep a great motivation to stick to the cutting edge.
Okay, and thank you so much. And Juan, we're going to take another question. Juan has raised hand. Do you want to just unmute yourself and ask questions?
Yes. Can you guys hear me?
Yes.
Yeah, I'm a little curious about the water line break prediction tool that you show us, Justin. I'm actually working on a project for another class right now, and it was literally about that, like how we can predict the water main break. So I'm a little curious about the variables or attributes that you use. Is it historic line clicks or just like other?
Yeah, so just to be transparent, it's not in place today. It's something that we're working towards, right? So we don't have it today. But to your point, all of those variables, historic breaks, soil conditions, I'm sure seismic activity is going, where we have faults is going to come into play. There's also some of the areas like in the Palisades on the coastal area, there's slumping that occurs. So that comes into play. So, soil conditions, historic breaks, the age of the pipe, the material of the pipe, all of these factors will be considered. Now, that being said, in order to really bring these models to fruition, we're going to be working very closely with our engineers, right? So I'm on the IT side of the house, right? GIS is only one of the areas that I'm responsible for. So we always work very closely with our business partners. They help drive our solutions. So it's a very iterative, collaborative process, and we're going to be relying heavily on our engineers to tell us what factors they're looking for, and then our teams take that input and help build the models and bring these tools to production.
Thank you.
I hope that helps. And I'm sorry I don't have something that I can actually tell you how we did it, because it's still a work in progress.
Thank you so much.
Sure.
We're going to take one more question from the conference room here.
Yes, good afternoon. Thank you for having this conference. I appreciate it. I'm a newbie at some of the deep neural learning networks. So I was wondering, as we're defining AI as more of a generative, agentic planning, is there any consideration or any use of like CNNs, convolutional neural networks, or LSTMs for this geodata that we're processing?
Any taker?
You're welcome to explore our paper. That can be a kind of an outline that you can see there, what types of existing CNN or ANN existing over there. And then in terms of the technical part, there are many YouTube videos can be a fantastic teacher. Like even myself, I teach at CNN by watching the YouTube videos. There are any animated videos, very detailed, illustrate how these neurons work and how they split and all of that. So that can be a good starting point. It's very easy, especially for new beginners.
Thank you.
Yeah, but of course there are tons of available resources online, like the Google one, the Google AI free courses. Those are also that you can take advantage.
I'm in college now for that.
Oh yeah? Okay, then that's great.
I don't have the interaction though between Geo and that yet.
Yeah, but that one is like more helping you to understand the AI, the function of the AI, and then the Geo AI needs to be stacking on the top of, you have fundamental understanding of what is geospatial thinking, right? What is the geospatial relationship? What is the geospatial weights? That kind of thing that's adding to the top of the AI comes together to be a Geo AI.
Thank you.
Yeah.
All right. So if there's, do I skip any questions? Anyone, the last question? If not, I'm gonna share a couple slides here, and thank you everyone to be here. We had our sets of our great panelists. We also want to thank SSI having this opportunity for GIS Day event. There's one more event for today at 4 p.m. It will be a workshop, a Geo AI workshop that SC Mappers, our student group, coordinate. And it's in person only, and I wish all of you can join. I think they will meet here at 4, okay? And I want to thank all the panelists to be here, giving a tremendous contribution and, really useful information for our students and our other attendees. Stephanie asked if the slide's going to be available. I will actually ask our panelists first if that's okay to share. Then I will be sending that to. I think we will have a registered list, so we'll send it through that list to all of you. Okay, and also we can share the recording if any of you want to review that as well. Okay, thank you everyone, and thank you Justin, Greg, and Matt, and Dr. Wang to be here. I hope you guys learned something from today, and I myself learned a lot about the GeoAI, and there's so much more to learn, so much more to follow about how industry and academia, everything gonna follow in this trend that we cannot avoid, right?
And one more thing is I took some photos from the backboards, without the space here, but we later on probably gonna post them to the social media platform. So I'm just getting permission from everyone to see if you're okay with that. But that's from the backside. Okay.
Yeah, we're gonna share some photos and post on our social media, and hope you're okay with our panelists and then all of you here in the room. All right, thank you everyone. And then the last is, if you guys find like there are some cameras turned on or not, like then they disappear. That's my student, because I give them extra credits to join that, and they have to show they're here, so they show up and then they disappear. Yeah, but happy GIS Day, everyone. Enjoy learning, and I'll see you guys in the next event sometime soon. All right, take care.